This conference will now be recorded.
Hello everyone, good evening. Can you see my screen everyone? Can you hear me? Am I audible?
Yeah.
Fine. Yeah, so we already completed 3 demos, right? So DevOps introduction, cloud introduction, so technical questions and general questions. 3 demos completed, right? So anyone newly joined today? So this is the first session you joined. So anyone joined first session today? Can you share your WhatsApp number and email address in the chat?
I already shared my email ID and name.
Right. Okay. Fine. So this is my mobile number. You can take down this number. So everyone, you guys, you can take down this number. 96422111711 is my number.
Okay.
Fine. Yeah. So today we are going to discuss about servers networks basics. Okay. Before going to the subject, before going to AWS, first we need to understand servers and networks. What is server? What is network? What is switch? What is router? What is load balancer? What is IP address? What is subnet mask? Gateway? So these are all very important. So the terminology is very, very important. So first we need to understand this terminology. So before going to AWS, okay, yeah. So we already created a WhatsApp group and people added into WhatsApp group. So still few people not added into WhatsApp group. So if you are interested, you can add into WhatsApp group, right? So today also we gave the same link, meeting link. So tomorrow the meeting link will be completely changed. Online meeting link will be completely changed tomorrow. Yeah, so if you are interested, you can add it to WhatsApp group as soon as possible today or tomorrow morning. Fine. Yeah. So let's get started. So I give you time for asking questions. If you have any questions, you can hold on for some time. Okay. So I give you time for asking questions. Okay. So these are all very important basics before going to AWS. We need to understand all these basics. Fine. So today's agenda here is what is server, types of servers, server client model and best practices, server architecture, what is operating system, types of operating systems, what is network, types of networks, what is IP address, what is subnet and gateway, router, firewall, failover and load balancer. So these are all very important. Okay. Yeah. Today we discuss about server, types of servers, server client model, server architecture. So this will take 1 hour up to here. So up to operating system we can discuss. This will take 1 hour. Okay. So tomorrow we'll discuss about networking, network part. Fine. Yeah. So basically, what is server? Anyone having idea what is server? What is server? Anyone? The admins, the people who are working as the admins, server admins.
Virtual machine it is.
Sorry.
Virtual machine.
Virtual machine. Okay. Fine. Any other answers? Anyone? Yeah. Server is a computer. Simply you can say server is a computer. That server that serves information to other computers called clients like workstations, so laptops or desktops, right? So server is having high computing power. So normally desktop and laptop we use only one RAM module and one processor and one CPU, right? So even we can use two RAM models also, two or three RAM models we can use. So even storage also you can use two, right? But server is having multiple RAM modules, multiple storages, multiple processors, right? Yeah, server is having more redundancy. Redundancy is nothing but yeah. So whatever the data we are storing on the server, that will be available in case one disk is fail, one processor is fail, so one RAM is fail, server will not be down. Redundancy is nothing but availability, right? Yeah, see here. A server is a computer that serves information to other computers called clients, can connect a server through either a local area network or wide area network such as the internet, right? Server is a computer. It serves information to other computers called clients. So clients are nothing but desktops and laptops. Normally, developers, testers, what they will do, they connect servers using laptop or desktop. They connect servers through either LAN or WAN or Wi-Fi. They can connect the servers. They develop the code on servers, right? Yeah. Now types of servers. Types of servers. What are the types available in the data center? Okay. So first one is blade server, rack server, tower server. Let us go with one by one. Blade server. A blade server is a modular server that allows multiple servers to be hosted in a smaller area. See here. So this is the container. Inside of this container, we insert thin servers, which are blade servers. These are high performance servers. These are high performance servers. So enterprise level data centers, we use the blade servers, right? Yeah, these servers are physically thin and typically only have CPU, memory, and integrated network controllers, right? Sometimes storage drives inbuilt. Fine. So without storage, how can we install the operating system? See here, only have CPU, memory, integrated network controllers, right? Sometimes storage drives also inbuilt. So normally this thin servers, this blade servers, we can connect external storages. External storage like EMC storage, Dell storage, HP storage, so NetApp storage. We are using different storages, right? So from that external storage, we can attach the LUN. LUN is nothing but logical unit number external storage. External storage that we can attach to the blade servers. So blade servers often seen in large data centers and like enterprise level data centers, we use the blade servers. These are a bit costlier also. These servers are high performance servers and we use in large data centers, and these are bit costlier, high costing, right? Yeah. Next one is a rack server. Rack server is a server mounted inside of a rack. Rack servers are typically general purpose servers that supports a broad range of applications and computing. So most of the data centers we are using rack servers. So this is one of the big container. Inside of this container, we can insert 24 servers, 24 port racks, 48 port racks, like that, 36 port racks, right? So we can insert servers and we can connect power, network, and we can install operating system, applications, patches, plugins, and we can hand over to project. They can access through network, right? So these are the general purpose servers. Yeah, most of the data centers we are using this rack servers. Okay. So next one is a tower server. Tower server is a, yeah, let us go with this. See here, tower server is a computer that is built in upright cabinet that stands alone and that is designed to function as a server. So this is standalone server. So this is bit older server. So here we connect to one monitor, CPU, one monitor and a mouse, keyboard. So inside of this tower, we can configure the CPU, right? So this is a bit older server. Currently, we are not using, right? So before going to cloud servers, first we need to understand physical servers. That is why we are discussing, right? Yeah. Next one, client server model. So this is server. These are the clients. Either we can use the desktops or laptops. We can connect our server through either local area network, LAN or WAN or Wi-Fi, right? So yeah, when we request, so when we try to communicate server, when we give the request, server will give response, right? So immediately we can take the data, we can access the data, we can modify the data, we can change the data, so whatever, right? So server is a computer. It serves information to other computers called clients, which are either desktops or laptops, right, through network. So this is another model, server client model. So either we can use desktop or laptop, or even we can use tab also to connect our servers through internet. Fine. Now let us go with the server architecture. So what is server architecture? Server architecture is the foundation layout or model of a server based on which a server is created and are deployed. It defines how server is designed. Now let's go and discuss about few examples of this servers. Okay. Yeah. Fine. Server architecture. So initial phase of implementation. Initial phase of implementation. So this is the first phase. We can say this is a first phase. Phase. So in 1990s and early 2000, in 1990s and early 2000, how the project teams used to configure the servers, how they used to design the servers. Let's try to understand here. Okay. So this is initial phase of implementation. So this is first phase of implementation. In 1990s and early 2000, how the project teams used to configure the servers, right? How they used to deploy the applications. For example, so here we have four applications are available. So which are Java and .NET, or else we can say Python. Someone unmuted. Priyanka, can you mute yourself? So I can mute. Yes. I give you time for asking questions. Wait for some time. Okay. Yeah. So here we have four applications: Java, Python, and a Tomcat, and also we can say something like another application, .NET, right? So four applications are available here. So in 1990s and early 2000, the project teams used to design the servers. So for each server, they used to design one application. For each server, for one application, one server, they used to design. So here we have four applications, right? So they used to take four servers like this, four servers. For each application, one server. In 1990s and early 2000, so the client project teams, they used to design like this. For example, yeah. So by the time in 1990s and early 2000, highest capacity of the storage is 1 GB. 1 GB is the highest capacity of the storage. So these are all 1 GB storage servers. These are all 1 GB storage servers. 1 GB. Right. Yeah. So here four applications, four servers. Okay. So here Java deployed. Okay. So for example, Java occupied 300 MB, right? So here what will happen? Remaining space will be wasted. Java occupied 300 MB, 700 MB space will be wasted. 700 MB space will be wasted. Okay. So Python occupied 350 MB, for example. Remaining 650 MB will be wasted, right? Because one server, one application, right? Yeah. So here remaining space will be wasted. So which is 650 MB will be wasted. Next one is Tomcat. So this is the application server. Tomcat application. Tomcat occupied 400 MB. So remaining space 600 MB will be wasted here. Right? Same way .NET. .NET occupied, so here 450 MB, remaining 550 will be wasted here. So each server, they used to deploy only one application, right? Fine. So here what will happen? So server utilization server utilization is very less, and hardware costing, by the time hardware costing, it was very higher. So in 1990s and early 2000, even though, so desktop costing, very higher costing it was, right? Even laptop costing and server costing, hardware costing, even 1 GB storage costing, too much cost by the time, right? So here server utilization is very less, but hardware costing, it is very higher, right? So project teams used to spend more, so project teams used to spend more budget for the hardware by the time, right? So that is why slowly after 2000, what happened? So this is actually failed model. This model is failed, initial phase of implementation. So this is failed model. Okay, slowly what happened in second phase of implementation? What happened here? Project teams used to take one high end server, one high capacity server. They used to deploy all the applications on same server. So Java, Python, and Tomcat, and also .NET. So they used to deploy, in second phase of implementation after 2000, they used to deploy all the applications on same server. So they used to take high-end server, one server, they used to deploy all the applications. So what will happen here? So here, Java user may access Java application, Python user may access Python application, Tomcat user may access Tomcat application, .NET user may access .NET application. So four people are accessing same server, right? So respective application they can access, right? So here what will happen? Java user may, it may be chances to access Python application also. Python user may access Tomcat also. There may be chances to access, right? So Tomcat user may access .NET also. There may be chances because four people are logging into the same server, right? They can access other applications also along with the respective applications. There may be chances because they are logging into same server, right? For example, four people are staying in 2 BHK flat. So two people are staying in one bedroom, two people are staying in other bedroom. The four people commonly access kitchen and dining, right? Same way, here also, four people are accessing their respective applications. Along with that, there may be chances to access other applications also, right? That is one drawback. And also, in case this service crash, what will happen? All the applications will be gone. That is why this is also failed model. This is also failed model, right? So slowly in third phase of implementation, what happened here? So virtual servers came into the market. Virtual servers came into the market. So what is virtual server? Anyone? What is virtual server? Anyone having idea? Virtual
On
server.
physical server, we have to install the hyperscale and we have to virtually we will use on that.
Fine. So virtual server is a imaginary server, which is not physical, right? Virtual server is a imaginary server, which is not physical server. We can create virtually. We don't access physically. We connect through internet. We can create virtually, logically, right? Virtual means which is not physical, right? So backend there will be a server, physical server. On top of that, we can create the virtual server. Fine. So my voice is breaking. So can you confirm one more time, everyone? So Sandhya saying my voice is breaking. Can you confirm anyone?
Oh,
Is it fine
no,
now?
sir, it's fine. Yeah,
It's fine, right? So Sanjay, you can check your internet connectivity. So I have internet connectivity, good connectivity is there. So no issues my side. Okay. So my side full signal is there. Okay. So you can check your end. Yeah. Fine. So virtual servers, which are not physical server, we can access virtually. So which are imaginary servers. Okay. We can use either cloud servers or VMware server or hypervisor server or Citrix. So many. Yeah. So we have different layers available. Okay. Yeah. Now, third phase of implementation. In third phase of implementation, so project teams used to configure. They started using virtual servers. Still we are using in real-time projects. Still we are using, right? But here also some drawbacks are there. What are those? Let's try to understand. For example, I take one physical server, which is, we can say, base OS. This is base OS, base operating system. So this server is a high-end server. So here RAM I can take 48 GB, CPU I can take 32 core. For example, I'm saying storage 10 TB. So like that, I can take the high-end server. So on top of this, what I will do, I deploy one software, which is VMware or hypervisor, Hyper-V or Citrix. So any software. So these are the virtual softwares. So once you install the software, this will allow you to create virtual servers. So on top of this, what I will do, I create virtual servers like this. These are the virtual servers, right? So here you can deploy different operating systems like Windows 20, 25 latest OS, and here I can deploy RHCL Linux, Red Hat Enterprise Linux, and here I can deploy Ubuntu Linux version. Here CentOS. So again here I can deploy Windows 2022 like this. So these are all 25, 5 into 5, 25 servers. So as per the base server capacity, we can create the virtual servers. These virtual servers utilize the resource from base server, physical server. Okay. Yeah, fine. So currently also we are using virtual servers, but here we have some drawbacks. What are those? Let's try to understand here. Yeah. So here, so when we want to deploy operating system, we use the ISO image. ISO full form is International Standardization Organization. So it's the full package of the operating system. It is a full package of the image, full blowing operating system, we can say. So by using this ISO image, we can deploy the operating system, right? So this ISO image size would be minimum 6 GB to 18 GB. So ISO image size would be minimum 6 GB to 18 GB based on the operating system. So currently we are using Windows 2022 and Windows 2025. So minimum we required 17 GB, 16 GB like that. So CentOS, yeah, this RHCL CentOS minimum 6 GB or 7 GB required, right? So on an average, each server can take 10 GB, for example. So 10 into, we have 25 servers, right? 25 servers equal to 250 GB. So we need to spend for the only operating system, right? So here we need to spend 250 GB only for operating system. So on top of that, we need to deploy Java, Git, Maven, Ansible, Kubernetes, Python, whatever we require. So we need to deploy, right? That takes more space, right? So here in virtual environments, server side storage costing is very higher, right? So this is one of the drawback. And also, so here when we want to reboot the server, reboot server, reboot or restart both are same. It takes 4 to 8 minutes. So when we want to reboot any physical or virtual server, it takes 4 to 8 minutes. So normally when we reboot our laptop or desktop, so within a minute we can reboot. Reboot means restart. So server side it takes 4 to 8 minutes. So that much of time client will not accept. Client will not be allowed. Client will not allow that much of time, because so for example, if you deploy Python any digital application like Flipkart, Amazon shopping site, Myntra, Misho, these are all digital applications, right? So if you restart the server is taking 4 to 8 minutes. So that much of time client will not give time, because if the server is down for 4 to 8 minutes, what will happen? Client business will be impacted. So that is why client will not accept that much of time. This is one of the another yeah, this is also drawback. And also one more important one, deployment time and downtime is high. So deployment time, what is deployment time? Anyone? What is deployment? So
To execute the code.
sorry, can you come again?
To execute the code.
Execute the code. Okay. So yes, even the code also, or else we can deploy the applications like any plugins, any patches we can deploy. Deployment is nothing but installation, simply. So downtime, what is downtime, anyone? Downtime,
I think update it. Right?
right? So downtime is a maintenance time, maintenance time, right? So deployment time and downtime is higher in virtual server or physical server, right? So these are all the drawbacks. These are all the drawbacks. Still, we are using virtual servers, but most of the companies, what they are doing, they are migrating to cloud servers, and inside of the cloud servers, so we are using advanced tools. What are those tools we are using currently? So let's try to understand. Yeah. Now let's move to fourth phase of implementation. Fourth phase of implementation, which is very very important. Currently, it is trendy. So every organization, every project team they're using. Okay. Yeah. Fourth phase of implementation, which is Docker containers. Docker containers currently we are using. Okay. Yeah. In Docker containers, same as virtual environments, what we will do, we take one server here, which is, we can say this is cloud server. We can say this is a AWS EC2 instance. EC2 instance, AWS EC2 instance. EC2 instance is a server. This terminology is very, very important. In AWS, we can call it as EC2 instance. EC2 instance is a server. Okay. Yeah. So on top of this, we deploy one package, which is, we can say, Docker image. Docker image. So this Docker image will allow you to create Docker containers. On top of this, we can deploy, we can create, not deploy, we can create Docker containers. Right? These are the containers. Docker container is not a server. It's kind of a box. Container in general, container is a box. So it is a lightweight standalone executable program. We can move anywhere, we can use anywhere, right? So it is a lightweight standalone executable program, right? Yeah. So in this containers, we can deploy whatever operating environment we require. We can deploy here. So for example, I deployed here RHCL, Red Hat Enterprise Linux. So here I deployed SUSE Linux, SUSE. So here I deployed Windows 2025. Here I deployed Ubuntu. So whatever operating systems we required, operating environments, we can deploy here. So when we run the container, what will happen? Only in this container, bin and lib files will be created. Bin and lib files, binary and library files will be created. So whatever files required to deploy the war file or jar file or ER file, so normally developer develop the code in their local system, local workspace, local laptop or desktop. They move to servers, integrated servers like development servers, right? So once development is completed, testing is completed, they push the code to remote repository, which is GitHub. So in real-time projects, so currently we are using Agile methodology, right? In Agile methodology, how the flow will be happen, how the flow, right? So developer develop the code in their local systems, local workspace. Once the development is completed, they push the code to remote repository, which is GitHub. So GitHub is a remote server. Once the code is moved to GitHub, so from GitHub, Jenkins take the code and it will hand over to Maven. Maven convert into artifact, which is a war file, jar file, or ER file. That war file we can deploy onto respective target servers. That we already discussed. That we already discussed in first demo, right? So whatever the war file generated by Maven, those war files we can deploy onto respective target servers. So instead of deploying onto target servers, so in place of target servers, we use the Docker containers. So currently, most of the project teams, they are using Docker containers to deploy the applications. So for example, we are using applications like Flipkart, Amazon shopping site, Myntra, Meesho. These are all deployed on Docker containers. That is why, so when we raise any request, so it will be processed very faster. For example, we are using groceries. Yeah, we are booking groceries, right, through Jepto, Dunjo. So when we booked any groceries or any provisions, within 10 minutes we're getting the groceries, right? So because of backend, they have very good infrastructure like Docker or Kubernetes. So when we raise a request, immediately that will be processed. Even though, so recently I booked one mobile, so latest mobile, OnePlus mobile. So the Flipkart team, they delivered within 4 hours. Within 4 hours they delivered. So because, yeah, so when we raise any request, that will be processed immediately, right? Very faster. So because they are using Docker Kubernetes in backend, right? So here when we run the container, instead of the container, only binary files will be created. So this binary library file size, OS size would be here 200 MB only. So here ISO image size would be 4 GB to 18 GB, sorry, 6 GB to 18 GB, but here 200 MB only. So whatever the files required to deploy the war files, those files will be created here, not entire image, right? So here in this ISO image, all the plugins, patches, graphics, paintbrush, media player, everything will be available. But here only library binary files. So here both are same functionality, right? But so when we have lightweight, less size, this contest would be very faster, right? So we can run the applications very faster, right? And also when we restart container, when we reboot container, it takes 15 seconds only. So contest will be restarted within 15 seconds, but here 4 to 8 minutes. Here no downtime, right? 15 seconds. So just quickly the contest will be restarted. And also deployment time and downtime is very less here. And the downtime is less, right? Yeah, so these are all advantages. Moreover, license costing is very less here. License cost is less, cost effective. This continuous license cost is very less. So these are all the features available here. That is why most of the project teams, they are migrating their applications to Docker containers, right? So client always look for the cost saving. Client always look for the cost saving. So most of the organizations, they are migrating their applications to Docker containers. So currently Docker is, every organization they're using Docker. Docker is having huge demand. If you are good in Docker and Kubernetes, you can easily crack your entry. You can easily cope up in the projects, right? So Docker will go very deep dive. So practical oriented sessions. Okay. So Docker nearly takes 8 days. Okay, we'll go very deep dive. Even though Kubernetes also. Fine. So this Docker launched in 2013. 2013. Docker launched in 2013. So immediately, yeah, Kubernetes launched in 2014. So why Kubernetes launched immediately? So what is Docker? Anyone? What is Docker? Anyone? Anyone having idea? What is Docker? Docker is a container tool. Docker is a container tool. What is container? Container is a lightweight standalone executable program. It's kind of a box. We can move anywhere. We can use anywhere. It's a lightweight standalone, right? So what is Kubernetes? Kubernetes is a container orchestration tool. Docker is a container tool. Kubernetes is a container orchestration. Advanced to Docker, right? These two tools are very core tools, very advanced tools. So we'll
What is
go
the
to
Kubernetes from container?
container orchestration tool.
Okay.
Container orchestration. So what is orchestration? Anyone? Anyone having idea? Orchestration. What is orchestra? Anyone having idea? Orchestra. Orchestra అంటే ఏంటండి? Anyone having idea?
Is songs.
Yeah. So group of instruments together, they play the music, right? Which is orchestra. So in between that instruments, one person stands and move his hands, right? One person stands and move his hands. Is the orchestration. He control the instruments. He direct the instruments. The musicians. So he direct to the musicians. Is a daemon, right? So here same way Kubernetes also, it is a daemon. It is a orchestration tool which controls all the target servers, right? So Docker launched in 2013. Immediately Kubernetes launched in 2014 because Kubernetes is having very advanced features. Advanced to Docker. Kubernetes is advanced to Docker. This is entry question. This is entry question. Okay, and also Docker supports 95,000 containers. This is also entry question. Kubernetes supports 3 lakh containers. Advanced Docker, right? So yeah, we have nearly 8 to 9 differences are there while working on Kubernetes and Docker. I give you all the differences. So this differences are very important. Most of the interviews we are getting these questions, entry questions. Okay. So currently most of the project teams, they are migrating their applications from virtual servers to Docker containers because so cost saving here and very quickly we can access the containers, we can move anywhere, we can use anywhere. So when we restart container, within 15 seconds we can restart the container, right? So these are all advantages of Docker containers. So currently every project team they're using because yeah, so everywhere we are using digital applications, right? Digital applications like Amazon shopping site, Myntra, Meesho, Flipkart, right? So most of the digital applications we means project teams they hosted in Docker containers. Fine. Any questions and
See,
anyone having any questions so far? Yeah, go ahead, Sai Prasad. Go ahead, please. Clear, right? Any questions on anyone? Anyone having any questions so far? Yeah, fine. So server architecture. See here, this is the server architecture. While working on AWS, I explain this architecture. Okay. So different devices we connect. Okay. Yeah. Next one is what is operating system? What is operating system? Anyone having idea? What is operating system? So we are using Linux, right? In our systems, in our lab or desktop. So what is operating system?
It is the interface between the user and the computer.
Okay. Yes. So it is the interface between the user and the interface between user and the computer, right? Yeah. So computer hardware always understand binary language. Computer hardware always understand binary language. What is binary language? Zeros and ones. 000 001 100 111, right? So computer hardware always understand binary language, but human will not understand binary language. That is why we require one translator. So which is operating system. So operating system is a interface between user and the computer hardware. Interface, right? See here. This is the definition. Operating system is an interface between user and the computer hardware. The hardware of the computer cannot understand the human readable language as it works on binaries, that is zeros and ones. So in such case, we need an interface which can translate human language to hardware and vice versa for effective communication, right? So it is a operating system is a interface between user and the computer hardware. Now see here. So this is hardware, this is end user. So in between, so between this end user and hardware, we require one operating system. It can be any operating system, Linux or Windows or Mac OS, whatever, right? So types of operating systems. What are the types available? Single user, single tasking operating system. So in this type of operating system, only one user can log into the system. He can perform only one task at a time. So for example, here MS-DOS, Microsoft Data Operating System, old operating system. So in this type of operating system, so only one user can log into the system. He can perform only one task at a time, right? So second one here is single user multitasking operating system. So in this type of operating system, so multitasking, single user multitasking, right? So one user can log into the system. He can perform multiple tasks at a time. For example, Windows. So in Windows, one user can operate multiple tasks, right? So while browsing internet, we can operate the background audios. While working on any tasks, we can run the background audios. So one user can log into the system, he can perform multiple tasks at a time. So single user multitasking operating system. Next one is very important. Multi-user multitasking operating system, which is Linux, Unix. Yeah. So multiple users, they can log into the system, they can perform multiple tasks at a time. For example, so developer develop the code, right? So as a DevOps engineer, as a cloud engineer, what we will do? We deploy the applications on respective target servers, right? So while deploying the application, developers log into the servers, testers log into the servers, DevOps engineers also log into the servers. They perform their own tasks. So Linux allows you to access multi-user multitasking operating system means multiple users they can log into the system, they can perform multiple tasks at a time, which is nothing but yeah. So multi-user multitasking, which is Linux and Unix. Clear, Andy? Any questions here? Fine. Yeah, so computer networks we'll discuss tomorrow. So networking concepts are very, very important. So here IP addresses, subnet masks, gateways, right? So firewalls, routers, failure words, these are all available. So we'll discuss tomorrow. So this will take 1 hour. Okay. So the people who are not added into WhatsApp group, you can add into WhatsApp group today or tomorrow. So once you make the fee, you can share the screenshot to me or institute number. We'll add into WhatsApp group. Okay. Yeah. So for every concept, I share the document with you. So I upload into Google Classroom, Google Drive. So we provide you access. The people already added into WhatsApp group, you'll get the access, right? Very soon. Yeah, all the documentation recordings will be uploaded into Google Classroom, and also running notes also I provide you, right? Yeah. So if you are interested, the people who are not added into WhatsApp group, if you are interested, you can add into WhatsApp group today or tomorrow morning. So tomorrow onwards, link will be completely changed. So 4 sessions completed, right? So DevOps introduction, cloud introduction, technical questions, general questions, and servers basics. So tomorrow we'll discuss about network basics. So day after tomorrow, we'll start AWS. Okay. Any questions, Andy? Anyone having any questions so far? So my number already provided. So my mobile number is 96422111711. So if you have any questions, you can reach out to me. You can call me, WhatsApp me. So we'll discuss. Okay. So we provided already institute account details, right? So you can make the fee and you can add into WhatsApp group as soon as possible. So tomorrow onwards, link will be changed. Fine.
Okay.
Yeah. So we can wind up here. Fine. So tomorrow also same timing. So link will be changed tomorrow. We'll provide you in the group. Okay. So the people who are not added into WhatsApp group, you can call me, you can WhatsApp me. We'll discuss and we can add into WhatsApp group. Fine. Yeah. Thank you all.
Thank you, Ram.